So I actually got the acid in the end. Did you get the base?
Oh yeah, I've been practicing it. Oh, I'm ready.
No.
No?
No, not that kind of base.
Oh, so you need a double bass. I got a double bass as well. I got it the other day.
So you haven't bought me Ferrero Rochers, but you've bought a bass and a double bass, and you haven't bought the right bass. I wrote you a memo, look, greater than 7.
Right. Oh, that is an issue. I don't think they sell that at the music shop.
You know what? I'll just get it. I'll buy it myself.
Okay. Well, that's very kind of you, mate. Thanks.
If you do owe me Ferrero Rochers, though. So, acids and bases. We did have a practical, but he forgot the base, so we can't do that. Do it in another video. So, acids and bases, you're familiar with the idea, I'm sure. Acids, pH of less than 7. Bases, or alkalis, pH greater than 7. And if it's 7, it's...
Water, well, neutral, but
neutral.
Water is an example.
So, on this side in red, we've done our acids. You have strong acids and weak acids. Can I have an example of some strong acids?
You can. H2SO4, which is sulfuric acid, is a strong acid.
Hydrochloric acid?
Yeah, strong acid as well. Would you like a weak acid?
Yeah.
A citric acid would be good.
I don't know the formulas of these. You've got ethanoic acid, methanoic acid, stuff that's in ant bites. That is acid. HNO3? Yeah, nitric acid, stuff like that.
Yeah. And then you have bases. In blue, which is stuff like...
metal oxides, magnesium oxide, copper
oxide.
oxide.
Yeah, all of those.
We've got ammonia, NH3. We've got something called amines, which is something like NH2, NH2, and just the ends bonded together. They're called amines.
Yeah. And
stuff like that. And then we've got magnesium hydroxide and stuff.
Which fall into a different bracket.
It does indeed.
So,
a different colour. Oh,
purple pen. It's the newest purchase
of the
Clever Studios, absolutely. And it's an alkali. The difference between an alkali and a base, well, some kind of isn't one. An alkali is a type of base that dissolves in water.
Yes, and this OH means it dissolves in the water. It can split into ions, Mg2+, and that'll be a 2, and OH minus. Now, NH3 is a base, but it's also an alkali. It's in both categories. And the reason for that is it can dissolve in water, but it's quite awkward and creates a reversible reaction. So it's classed as an alkali as well, but it's also a base.
Whereas MgO doesn't dissolve in water at all.
No. Now all alkalis are bases. You could get away with calling this a base. You couldn't get away with calling we couldn't get away with calling them alkalis.
Yeah.
And these you should call alkalis. If they dissolve in water, that's what you call them, but they're all bases.
Absolutely. And they react in different ways. These two react with each other. Like the further they are on this side, they try and get to the middle.
Yes, that's what they try and do in their reactions. Acids are called proton donors as a definition.
Yeah.
And that means they donate these H's, these H pluses or protons.
Yeah. And these are called proton acceptors because they accept the protons that the acids give.
Acids have dissociation. If they completely dissociate, it means they're a strong acid. They can react really well, like these two I've got up here. This one will react even quicker because it's got H2 and it will properly dissociate. Weaker acids partly dissociate. And these are all words you need to know, and it's all to do with the splitting up. So, HCl is a good example. This is a strong acid, and it will split completely into its H plus and Cl minus. So there's its proton donor, and it's completely split.
It'll do this really quickly. So weak acids and strong acids will do the same reaction, just strong acids do it a lot faster.
So we get up an example of a weaker acid, ethanoic.
Okay.
CH3COOH.
So what this one does is it only partially dissociates. That means it only gives only one of its hydrogens at a time. So it splits that way it's doing now. It only loses this one.
So it's only partially dissociated, so it'll be a much slower reaction.
So it does that bit,
a weak
and then the next one.
If you had this as a strong acid, if it was a strong acid, it wouldn't be something you'd put on your chips, because this is vinegar here.
Yeah.
If you got bit by an ant and it was a strong acid, it would do a lot more damage, so it's a weak acid.
Yeah.
And the reactions of these is in the next video, so this is just going over it. Silly cracker over here didn't buy the right base.
Oh, I'm sorry, I got on that one. Looking at us and Pretty sure we can get that 7 hours, right?
Yeah, I'm sure we can. You just fill in your details.
Absolutely.
Black dot way. No. Oh no, no,
What?
no.